So you think you're fully prepared for the 0625 physics exam just because you memorized an entire textbook of equations? Yeah, think again. Every single year, thousands of students walk into that exam hall totally brimming with confidence, only to get absolutely crushed by the mark scheme. So today, we're tearing down the high-stakes reality of this paper, and I'm going to show you exactly how top-band students navigate motion data to secure maximum marks.
Let's just destroy this massive, incredibly dangerous study myth right out of the gate. The idea that cramming formulas into your head guarantees an A-star, complete fiction. Look, you might know that speed equals distance over time, V equals S over T, but raw memory is nowhere near enough to pass, let alone excel. Examiners aren't testing your ability to be a human calculator. They're aggressively testing your ability to apply those concepts to totally unfamiliar data, weird investigations, and complex physical models. If your whole game plan is just repeating equations, well, you're walking right into a trap.
And the immediate risk of that flawed strategy is brutal. 0 marks on calculation and application questions. That rapidly drags down your grade boundaries. The stakes here are incredibly high. Relying strictly on raw memory means you totally miss the nuanced context clues buried in the question. You'll forget to convert units, you'll misinterpret which variables the examiner actually wants, and you'll end up writing conclusions that the data literally doesn't support. 1 or 2 of these memory-based slip-ups, painful, but doing this consistently will completely derail your final grade.
To understand this, let's look at why ordinary revision completely fails. When we dig into the actual Cambridge Examiner reports, a super clear pattern of painful learner mistakes pops up right away. Students are constantly losing crucial marks, not because they don't know the physics, but because their exam technique is just poor. They leave out units, they round numbers way too early in multi-step calculations, which totally ruins the final answer. They give these vague, generalized explanations instead of precise scientific reasoning. Or they mislabel graph axes and use entirely wrong variables. These are unforced, devastating errors, and trust me, ordinary flashcard revision is never going to fix them.
Okay, so how do we fix it? We use the Memory Palace framework. This is a brilliantly effective, foolproof 4-step system that elite students use to lock in top-band marks every single time. Here's how it works. Step 1 is the concept. You figure out exactly what physics principle is actually at play. Step 2 is evidence or data. You extract the specific numbers right from the source, graph, or table. Step 3 is scientific reasoning. You actively connect that concept to your data. And finally, step 4 is examiner wording, structuring your final answer using the precise language the examiners want to see. This system permanently replaces the old myth of just memorizing equations.
Now pay very close attention here. In a moment, I'll show you the examiner clue that changes the answer completely. But first, you need the framework that makes that clue obvious. Seriously, without this foundation, the secret I'm about to share will just slip right past you when you're under the pressure of the real exam.
Section 1. Analyzing motion and speed data.
Let's put this into practice with some visual evidence. Imagine a multi-flash photograph of a golf swing. To find the actual speed at any precise instant, we need to know the distance moved in a very, very short interval of time. In this kind of setup, the golfer is photographed while a flashing lamp illuminates him exactly 100 times a second. By measuring the distance the club moves between those rapid flashes, we can determine instantaneous speed. Using this exact method, the speed of the club head right as it hits the ball actually reaches an astonishing 200 kilometers per hour.
Based on that evidence, we need to lock down our exact Cambridge terminology. Speed is formally defined as the distance traveled per unit time. When the distance traveled is s over a short time period t, the speed v is simply v equals s divided by t. Remember, this is your concept phase in the framework. You absolutely must state this definition precisely as distance traveled per unit time. Don't just say something vague like how fast something goes. Precision is exactly what earns you the marks.
So, the really crucial point here is understanding the difference between instantaneous speed, like that golf club impact, and average speed over a long journey. Take a look at this data. If a car travels a total distance of 300 kilometers in 5 hours, its average speed is 300 divided by 5, right? Which equals 60 kilometers per hour. But think about it practically. The car's speedometer isn't going to sit perfectly at 60 kilometers per hour for an entire 5-hour drive. It speeds up, it slows down for traffic, it stops entirely at junctions. The speed varies constantly. That is exactly why we have to state the average speed using the formula: total distance traveled divided by total time taken.
All right, let's put your examiner hat on for a quick interactive challenge.
I want you to mentally pause, predict, and spot the error in this scenario. A student is given that exact car journey data we just discussed, 300 kilometers in 5 hours, and they're asked to calculate the average speed for 3 marks. They know the formula, they know the numbers, but they still end up dropping marks. Can you guess exactly where they went wrong?
Okay, let's pit the flawed student answer against the improved top band answer. The flawed answer writes, speed is 60 because 300 divided by 5. Now this student probably thinks they totally nailed it. They got the right final number, sure, but now look at the top band answer. Average speed equals total distance divided by total time, which equals 300 kilometers divided by 5 hours, which equals 60 kilometers per hour. That top band answer secures all 3 marks effortlessly. The flawed answer, it loses marks for failing to state the formula clearly, failing to show units during substitution, and utterly failing to include the final unit of kilometers per hour. A number without a unit in physics is basically meaningless to an examiner.
And that brilliantly illustrates the withheld examiner clue I promised you earlier. The secret is this: substituted values with exact units. Examiners are explicitly hunting for your substituted values accompanied by their correct units right there in the method steps. If you just write 300 divided by 5, you risk losing your method marks if your final calculation ends up wrong. But if you write 300 kilometers divided by 5 hours, you are clearly demonstrating your scientific reasoning and speaking the examiner's language. It proves you genuinely understand the physical reality of the data, not just the math.
Section 2. The final revision step, an exam check system.
To permanently replace that dangerous myth of just memorizing equations, you need to adopt this final exam check system. Basically, whenever you finish a question, run through this rapid-fire mental checklist. Did I use exact Cambridge equation terminology? Did I show my substituted units in my working out? If there's a graph, did I double-check the axes scales and units before calculating a gradient? Is my final answer to the correct number of significant figures? And finally, are my conclusions genuinely supported by the numerical data provided? This is the high mark system in action, guys. This is exactly how you stop hemorrhaging easy marks.
But look, mastering this single topic is really only part of the battle. Knowing how to apply this framework is pretty useless if you don't know exactly which topics to prioritize right before you walk into that exam hall. This explainer actually leaves an unresolved gap in your overall strategy, which is exactly why watching our last 7 days revision map is your mandatory next step. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Dive into the next explainer right now to unlock that final piece of your revision system. Because seriously, if you can't prove your methodology to the examiner, do you really understand the physics at all? I'll see you there.